Today we're looking at solving logarithmic equations, which I know we did a little bit of yesterday and we talked about. There are a couple of different ways that your logs can be written that determine a little bit the way that you solve it. Some of them are a little bit easier than others. These are all legitimate logarithmic solving questions. So the first one and the easiest one, I'm going to kind of jump around on here a little bit, so hang with me, are the ones when you have two logs already equal to each other. Okay? There's a property that's written at the top of this, and it makes perfect sense if you already kind of even think about it. If you have logs that have the same base, and they have two different things inside, that's only going to be true. They're only going to be equal if the inside parts are equal. So whenever I come down here to these questions number 7 and 8, if the log 4 of 3x minus 1 equals the log 4 of 2x plus 3, you can just cancel out the logs and solve the inside part. And again, that makes pretty good sense, right? Like, I mean, how else is that going to happen? So when you subtract your 2x and add the 1, you get x equals 4, and that's your answer. Okay. Same thing on the next question, right? These are the same thing again. I can ignore that. X squared minus 6 equals 2x plus 2. How do you solve this if it has an x squared in here? I hope you said by factoring, because we have factored enough this year that that should be your first instinct anytime you see an x squared. So I'm going to subtract the 2x over here. Again, I can't add that to either one of those things. I'm going to subtract the 2. When I do that, that gives me x squared minus 2x minus 8. Do my signs, that's a minus and a plus. What multiplies to be 8 and subtracts to be 2, that's 4 and 2. So x equals 4, x equals negative 2 are my two solutions. Yeah, good deal. I was making sure it worked. Yeah, we're good. Okay. Over here, here's another one. This is the best one. Cancel out the logs. What does x equal? Yeah, I bet you're hoping for a question like that on your test. Okay, so again, that's when a log equals a log. Man, why are there so many of these? They're too easy. Cool. Pretty simple there. The rest of your equations, when you don't have two logs, on every one of them, your first step needs to be to rewrite it where it's not a log anymore. So to do that, I'm just going to remind you a little bit. If I have log b of x equals y, let's say, then I rewrite it. The little number becomes the big number, and the other two switch places. Okay? So the first way I'm going to solve it is the one that I think that is the easiest. That's going to be when you're looking for your x. Okay? Because watch what happens when you're looking for your x. So that's like question number 2. Okay? I rewrite this where it's not a log anymore. That gives me 3 to the negative 2 equals 2c. Well, what is 3 to the negative 2? You should know by now that that's 1 over 9, because that's 1 over 3 squared, equals 2c. How do you finish this? By dividing by 2. What do you get when you divide 1/9 by 2? Remember, when you divide fractions, you keep, flip, change. So the 1/9 stays. The 2 flips to a 1 over 2, and you change it to multiplication. That's c equals 1 over 18. Okay. Here's another question that's very similar, just like this. Again, I'm solving for something that's on the inside part of the log. When I rewrite this, 4 squared is 16. That's 5x plus 1. Subtract the 1. That's 15 equals 5x. Divide x equals 3. Okay. Again, pretty simple. There are several more on here that are like this. This one right here, right? If I rewrite this, that's 8 to the 2/3 power equals x minus 5. Well, the first thing you're going to have to do is remember what 8 to the 2/3 power. That means the cube root of 8 squared. So that's 4 equals x minus 5. That should give you x equals 9. Okay. This question here is also like that. Rewrite it. That's 25 to the 1/2 power equals x over 2. 25 to the 1/2 means the square root of x. X over 2. I'm going to finish that by multiplying by 2. X equals 10. And one more that's set up like that one. That's number 10 right here. 8 to the second power equals 4x plus 4. 8 squared is 64. 4x plus 4, that gives me 4x equals 60. That gives me x equals 15. All right? So that's when you're solving for the thing that's inside the log. Okay? This one, question number 1, when you're solving for the y thing, that's actually very similar to what we did on 7.3. Okay? You have a log and you want to know what it equals, so you rewrite it. This is 2 to the 3x power equals 32. Well, just like we did yesterday, you have to rewrite this as 2 to some power, okay? So this is already a 2. Again, if this was like a 4, then maybe I'd have to break them both down to a 2. Again, just like what we did yesterday. So 2 to the 3x, if you remember, 32 is actually 2 to the 5th power, okay? Once you get here, now these numbers are the same. You can ignore them. That gives me 3x equals 5, which gives me x equals 5 over 3. Okay. Our last type, when you're solving for the b. Okay, so let's do that one here. When I rewrite this one, that's 2x to the negative second power equals 16. So this one's going to be annoying because it's a negative second. Let me actually work this one down here first, number 9. This gives me x to the third power equals 1,000. Okay. So one thing that you can do, you can do a couple of different things here. You should be able to figure this one out without doing anything else, okay? But one strategy, if you're not sure, is to flip that exponent and move it to the other side. Okay, so that gives me x equals 1,000 to the 1/3 power. Well, you should know the cube root of 1,000 is actually 10, and that's your answer. Here, again, there are 2 ways to do it, okay? Option number 1 is you can go ahead and say, well, this is just equal to 1 over 4x squared equals 16. You could solve it from there, okay? You're going to get the same answer. Option number 2 is to, again, flip your power and move it to the other side. That would be 16 to the negative 1/2 power. Those cancel. That gives me 2x equals, that is 1 over the square root of 16. That's 1 over 4. How do you finish this? By dividing by 2. Again, when you divide 1/4 by 2, that's keep, flip, change. It's going to be x equals 1/8. Again, checking this out, I would have got the same thing. Step 1 would actually be to multiply both sides by 4x squared. We can't solve for it in the denominator like that. Okay, so that gives me 1 equals 4 times 16 is 64x squared. I can divide by 64. That gives me x squared equals 64, 1 over 64. I'm going to have to take the square root to finish that. The square root of 1 over 64 is, guess what? 1 over 8. So either one of those methods would get you the same thing. It kind of depends on your problem on which one is easier. Okay? On the back of this, again, you're doing the exact same thing, but with inequalities. Okay? We are simply just solving these. I don't remember if there was anything fancy to this that we really did. The only thing you need to know is that you actually can't take the log of a negative number. If you're not sure, we haven't really talked about logs on the calculator before, but if I try to take the log of a negative number, it's going to say error because it doesn't have a real answer. So that's why I kind of paused back here on this question right here. Question number 8 told me that x is negative 2. That's actually not a legitimate solution because you can't take the log of a negative. And if I plug a negative 2 in here, well, that's negative 2 times 2 is a negative 4. Negative 4 plus 2 is negative 2. This would also be a negative 2. Negative 2 squared would be 4. 4 minus 6, negative 2. That's actually not a legitimate solution because you can't take the log of a negative. But they did that up here and they didn't say anything about it, which I think is very weird. But I'm not going to talk to the book people about this. So again, the first thing you have to do is you have to rewrite your logs again. Solve them just like you did. Okay, so this is 2 to the second power and then 2x. The only thing that, the thing that just gets tricky here is your inequalities, okay? Looking up here at the top, okay, right here, if you have a log that is greater than, okay, and your b's are greater than 1 and your x's are greater than 0. Well, x has to be greater than 0, and all of our b's are going to be greater than 1. We don't have any fractional bases down there, okay, because we really can't do that. Anyway, we're not going to do that. So whenever it is greater than, the log is greater than, then when you rewrite it, okay, the base part, the little number becomes the big number, becomes less than. Okay, so when I rewrite this one, when it was greater than, I have to basically flip my sign. Okay, so it was this way. If I rewrite it the way I do it, you have to flip the sign. That's just something you're going to have to remember to do. Okay, so let's just finish solving this one. Okay, so that's going to be 4 is less than 2x when I divide by 2. That gives me actually that 2 is less than x, or usually we say x is greater than 2. Done. Okay. When I get ready to do number 5, I would do the exact same thing. 5, 2, flip my sign x. That tells me that 25 is less than x, or x is greater than 25. Traditionally, we just like to have the x on the left side. It just kind of makes us feel more comfortable, I guess. When you get to a less than question, and here's where it changes just a tiny bit. 2 to the 4th. Again, I still flip my sign. Okay. I solve this, so 2 to the 4th is 16. Minus the 1, 15. Divide by 3. That gives me that 5 is greater than x, or that x is less than 5. Okay, that's a reasonable thing, but you have to add in that x is also greater than 0. Okay, it can't be less than 0. So whenever you have a less than question, whenever you're looking for that the log is less than, you have to add in the 0 portion. Okay. Whenever you have just a traditional like log equals log question down here at the bottom, then that sign stays the same. You don't have to worry about flipping this one. This is just going to be 5x is less than 30. That gives me x is less than 6. Done. Same thing here. X is less than 2x minus 4. I'm going to subtract the 2x. Negative x is less than negative 4. Or when I divide by the negative, x is greater than positive 4. Okay, so either one is true. On this one, I mean, we could make some arguments about 0 and stuff like that. X can be any number less than 6. That's not necessarily true. Because again, if this becomes 0, you're going to have a non-real answer. But I'm not as worried about you mentioning that here because this gets kind of complicated. But I would like for you to know that up here when we're talking about the less than questions. So again, like this one, 3 to the 3rd power is, I have to flip that sign when I'm solving. That's 27 is greater than x plus 3. That gives me, when I subtract the 3, 24 is greater than x, or x is less than 24, but it does have to be greater than 0. So I know that's a little weird, but you could rewrite your log in a different way where you didn't have to remember to flip the sign, but this is the order I like to go in. So then you flip the sign. It's not really that big of a thing to have to remember, but maybe it is. 4 to the negative 1/2 power, again, that's this 1 over the square root of 4, that's 1 over 2 is less than 2x when you divide by 2. Here's another fraction thing. That gives you 1/4 is less than x, or x is greater than 1/4. Again, I would take this top answer. You just need to understand that means the exact same thing. Okay, last example here, 27 to the 2/3 power is less than 6x. Again, that's the cube root of 27 squared, so that's 3 squared is 9 is less than 6x when you divide by 6 and reduce the fraction. 3 over 2 is less than x, or x is greater than 3 over 2. So again, if x is greater than, you don't have to worry about the 0. If x is less than, you really need to mention that it does need to be greater than 0.